As I'm sure you all know, technological advances have compressed more and more computing power into smaller and smaller packages. The desktop computers of yesterday are easily exceeded by the computing power of an average phone. Computers have become so compact and so seamless in appearance that it's becoming easier and easier to forget that they are complex systems composed of a variety of interacting parts. In this lesson, we're going to take apart a computer and examine how some of the bigger parts interact with each other. We're also going to begin examining how software interacts with computers. The goal isn't to make you an expert. I just hope to demystify computers for you a bit so that you're more comfortable talking about computer problems and better prepared to consider different ways to solve these problems. We might imagine 4 layers in a computer system: the user, the hardware, the operating system, and the applications. I'll discuss all 4 of these layers and describe how they interact. Layer 1 is the user, and that's easy enough to describe. The user is you. Well, you and anybody else who wants to accomplish some task with a computer. When you connect a computer to the internet, you connect to other computers, but you also potentially connect to countless other computer users. Most of these users are people who you want to connect with: friends, journalists, bankers, retailers, etc. But a few of them are cybercriminals of some kind, so keep that in mind. Layer 2 of the computer system is the hardware of the computer, its physical parts. We'll spend the bulk of this lecture describing hardware. We'll begin demystifying hardware by examining what we can see from the outside of the computer. Then we'll break open the computer and poke around at the hardware on the inside. To begin, let's consider a desktop system. We can see several different parts already: a monitor, a keyboard, a mouse, and a computer case, also known as a tower. Perhaps a printer is also lurking around somewhere nearby. The monitor, keyboard, mouse, and printer all need to communicate with the computer inside the tower, so they will usually be connected to the computer via cables. In some cases, these devices are able to connect wirelessly, either via Bluetooth connections or, especially in the case of printers, via a wireless internet router. But for the sake of keeping things obvious, we'll assume for now that these devices are networked together with cables. The devices that draw the most electricity, so the computer inside the tower, the monitor, and the printer, will all need a power cable. We didn't include power cables in this illustration, but you can imagine where they would go. Smaller devices, like the keyboard and the mouse, normally don't require a direct connection to a power outlet. The Universal Serial Bus, or USB, connections that connect the keyboard and mouse to the computer are built to carry both data and electrical power, and so low-power devices like keyboards and mice normally route electricity from the computer tower. They just borrow power from the computer itself. In the case of wireless keyboards and wireless mice, they will be powered by batteries, of course. Now, the primary function of a monitor and a printer is to display information. We can think of information flowing from the computer into the monitor and printer, which display it for the user. Have you ever thought of a printer as a very slow, paper-based computer monitor? In some sense, that's what a printer is. The primary function of a keyboard and mouse is to input information and input commands into the computer. We can think of the information starting with the user and flowing into the computer via the keyboard and the mouse. Most desktop computers will also be connected to the internet. For now, let's assume that they use a physical Ethernet cable rather than a wireless connection. Through this Ethernet cable, the computer can communicate with the internet, sharing potentially huge amounts of information with the outside world. So this is what the whole system looks like from the outside. Electricity flows from a power outlet into the tower, and from the tower, some of the electricity is allocated to the keyboard and the mouse. Electricity also flows from an outlet to the monitor and from an outlet to the printer. The computer sends information from the tower to the monitor or printer, which allows the user to see it. The user inputs information and commands into the computer via the keyboard and the mouse. Finally, the computer is able to trade information with other computers via its internet connection. Now let's open up the tower and see what's inside that. We should find a large greenish plate fixed to one side of the tower. This plate is called a motherboard, and all the hardware inside the computer is connected together through this motherboard. We should also see a small fan fixed to the motherboard. This fan marks the presence of the Central Processing Unit, or CPU, of the computer. This CPU processes information and executes a multitude of various instructions that the CPU receives from the software programs that are running on the computer. The overwhelming majority of actual computing that the computer does takes place here at the CPU. One helpful analogy is to think of the CPU as the brain that does the thinking in the computer. Though the CPU performs an astonishing number of computations in the blink of an eye, the CPU is a small device. It's just a small silicon chip. It's a lot smaller than the fan apparatus that covers it, and that's all you can see here in this picture. The fan helps to cool the CPU, maintaining it at an operable temperature. Near the CPU, we find small cards of random access memory, or RAM. RAM is the working memory inside a computer. If the CPU is doing all of the thinking, then the RAM provides content for the CPU to think about. Sometimes people will refer to RAM simply as memory. In computer language, the terms RAM and memory are informally interchangeable. If somebody asks how much memory is installed on a computer, they're probably referring to its RAM. And in these videos, I'm probably going to use the terms memory and RAM interchangeably. Near the front of the computer tower, where users normally insert disks and where the power button is normally located, we find two storage units in this computer, the hard drive and the CD/DVD drive. The hard drive contains a series of magnetic disks, together referred to as the hard disk, which can store a large amount of information. The hard disk can usually store tens or hundreds of times more information than can be held in the computer's RAM. For most computers, the hard disk is its primary storage unit, containing both data files, such as user documents, music, and photos, and program files, so files that tell the CPU how to run different programs. But users don't have to store data in the computer's hard drive. Users can also store files and programs on removable media, such as CDs and DVDs. Files stored on CDs and DVDs are accessible via a computer's CD/DVD drive. The advantage to keeping files and programs on removable disks is that they become easier to transport, and they're also safe if the computer or hard drive happens to fail completely. The advantage to keeping files and programs on the computer's hard drive are that they should always be accessible whenever you have access to your computer, and that they should load much faster from the hard drive than they would have from a CD or a DVD. Now, these days, people don't use CDs and DVDs nearly as much as they did, say, 10 years ago, but you still might see a CD/DVD drive on a desktop computer. Sometimes people confuse a computer's memory with its storage, but we will be using those terms in different senses here. Memory, like I said, is the RAM. It's the information that the CPU has immediately available to it. Storage, on the other hand, is all of the information that the CPU has access to through drives like the hard drive or the CD/DVD drive. There are other types of storage drives too, like say flash drives. A CPU might have access to information that's in storage, but for the CPU to perform rapid and efficient operations with that information, the CPU must first load that sort of information into its memory. To help illustrate the difference between computer memory and computer storage, I'm going to ask you to perform a little thought experiment. To start, close your eyes and picture your very first school teacher. Can you remember what he or she looks like? If you can't remember your first teacher, picture the earliest teacher that you can remember. Do you have somebody in mind? Now good. Open your eyes if you haven't already opened them up. Now consider this. How long has it been since you thought about that person? Probably quite a long time, maybe even years. In any case, I bet you weren't thinking about him or her right before I asked you to. When the memory of that person was sitting dormant in your brain, that was kind of like computer storage, like you'd find on a hard drive. It's in there somewhere, but you aren't doing much with that information. It's just sitting there. When you recalled that memory to your mind, that was kind of like computer RAM. You accessed some information from storage, and you began operating with it, so you were conscious of it. The last piece of hardware I'm going to discuss in this lecture are input and output cards. A motherboard will normally contain a number of expansion slots for various input and output cards. For example, this motherboard has a slot for an Ethernet card, and in fact there is an Ethernet card plugged into that slot. The Ethernet card has a port for an Ethernet cable, and this port will be exposed at the back of the computer tower so that the user can easily plug an Ethernet cable into the computer. The computer connects to the internet through this Ethernet card, and as you can imagine, the internet allows for both inputting information into the computer and outputting information from the computer. This computer also has a number of other slots for input and output cards, but in this image those slots are empty. Other common expansion cards include graphics cards and sound cards. Graphics and sound cards will have some sort of audio or video ports, which will be exposed at the back of the computer for user access. Upgrading the graphics and sound cards can improve a computer's audio-visual outputs, and so such upgrades are popular among gamers and artists. Now, so far we've been looking at the hardware on a desktop PC. I should point out that most notebooks, tablets, and smartphones have many of the same basic parts as a desktop. The main difference for these smaller devices is that the parts have been compressed and reconfigured to take up as little space as possible. A notebook computer is basically a desktop computer where the monitor, keyboard, and computer tower are all compressed into a package that's about the size of a notebook. Because a mouse doesn't really fit into a notebook, laptop manufacturers have replaced the mouse with onboard touchpad pointing devices. Tablets and smartphones come in even smaller packages, and they replace both the keyboard and the mouse with a touchscreen display. Tablets and smartphones also replace those boxy data storage devices from a desktop, like the hard drive and the CD and DVD drives, with internal flash-based storage. So that's the hardware of a computer. Now let's move on to the third layer of this computer system, the computer's operating system. The operating system is a large, complex program that runs on your computer. Windows, Mac OS, Linux, and Android are examples of well-known operating systems. If you have a computer, a tablet, or a smartphone, it probably runs one of those four. An operating system coordinates and facilitates the interactions between users, hardware, and software applications. Operating systems display the files that are available to the user. When the user commands the operating system to run a program or to open a data file, the operating system is responsible for accessing the appropriate file and coordinating its interactions with the computer's hardware. Pretty much every interaction that you have with a computer is mediated through the computer's operating system. The fourth and final layer that we're going to discuss in this lecture is the layer of computer applications. Applications are programs that are designed to perform specific tasks for the user. For example, most operating systems come with a calculator application that's pre-installed. Your web browser, such as Firefox, Chrome, or Safari, is another example of an application. The operating system displays which applications are available to the user, and when the user selects an application, the operating system opens the application and coordinates its interactions with the computer's hardware. Applications are normally stored on the hard disk of a computer, though it's possible to store them in other places as well, perhaps on a CD or DVD, or on a thumb drive. Okay, in this lesson I introduced you to 4 layers in a computer system: the users, the hardware, the operating system, and the applications. That will be all for now on demystifying computers. In part 2 of this lesson, we will continue to demystify computers by discussing what happens when you turn a computer on and when you run an application.